Okay, today we're going to be going over solving radicals and distributive property. This is topic number 19. Go ahead and press pause in the video and jot this down. The rest of the page is going to look like this, and then that'll finish out the first page. On the next video, we're going to do the backside. The backside will look like this. So just make sure that you have enough space front and back. All right, but today on today's video, we're only going to cover this first portion. So again, I'm just going to assume that you already copied this down, and we're going to go ahead and get started. So a radical is basically the same thing as a square root. Let me go ahead and write that on the side. Radical is the exact same thing as a square root. So you'll hear me go back and forth and say call it a radical sometimes, and then you'll hear me call it a square root another time. Basically, a radical or a square root is the opposite of squaring something. I want you to recall, like if I do something like this, if I have, I don't know, let's say 3 squared, what that means is 3 times 3, which is 9. So I went from squaring 3, and I ended up with 9 because 3 squared means 3 times 3, which is 9, okay? We are going to be going the opposite direction. A square root is basically saying what number got squared in order for me to get 4, okay? So there must be some number that when I square it, I get 4. Well, the square root of 4 must be 2 because I know that 2 squared means 2 times 2, which is 4. We'll try that again. Square root of 16 is something, so that means there must be some number out there that when I square it, the answer I get is 16. So then the answer must be 4. I know that the answer is 4 because if I take 4 and I square it, I get 4 times 4, which is 16, which is exactly the number that we got as an answer, if you want to think of it that way. Okay, so again, 49, what number is being squared in order to get 49? We're doing the opposite operation of squaring. We are square rooting, so there's got to be some number out there that when you square it, the answer you get is 49. That answer must be 7. I know this is true because 7 squared means 7 times 7, which is 49. And if we do this quickly, let's see, square root of 121. Square root of 121 must be 11. I know this because 11 squared means 11 times 11, which is 121. The square root of 100 must be 10. I know this because 10 squared means 10 times 10, which is 100. Square root of 64, that must be 8, because I know that 8 squared is 8 times 8, which is 64. And then the square root of 225, well, obviously that's 15. If you didn't know that, you will know that by the end of this course. We do use that square root of 225 quite a bit. I know that the square root of 225 is 15 because 15 squared is 15 times 15, which is 225. All right, so basically square rooting is just finding the opposite operation to get the perfect squares, right? So these numbers in here, they all happen to be perfect squares because they're all numbers that get some type of number squared to get that answer. Not all numbers are perfect squares. So for example, like the number 6, if you try to take the square root of 6, there is no number that when I multiply it by itself gives me 6. For example, 2 times 2 is 4. That's great. And then the next one, 3 times 3 is 9. So I skipped 6, 7, and 8. 6, 7, and 8 are not perfect squares. So that's exactly what we're going to be working on today. Now that you know how a square root works, right? We're finding what number squared gives me that answer. We're also going to be able to approximate what numbers, those numbers that are not perfect squares. So look at the next example. It says, between what two numbers is the square root of 30? There is no number that when you square it, you get 30. That's an integer, right? So let's see. If I do 1 squared, it's 1. I'm trying to get to 30. That didn't work. 2 squared is 4. I'm trying to get to 30. That didn't work. 3 squared is 9. I'm trying to get to 30. That didn't work. 4 squared is 16. I'm trying to get to 30. That didn't work. 5 squared is 25. I'm trying to get to 30. That didn't work, and that was too low. 6 squared is 36. I'm trying to get to 30 and actually went too far. Okay, so let's backtrack and kind of see what happened. Essentially, what I just found out was that I know that the square root of 25 is 5, and that number was too low. So I'm going to go ahead and highlight this in pink. Square root of 25 is 5, but I don't want the square root of 25. I want the square root of 30. So I'm going to go a little bit higher, and I know that the square root of 6 is 36. I'm sorry, the square root of 36 is 6. But that number was too high. So essentially what I'm saying is I know my answer has to be bigger than 5 because the square root of 25 is 5. But it's got to be smaller than 6 because the square root of 36 is 6. Notice how the square root of 30 is kind of sandwiched somewhere in between these two numbers. Okay, so I know my answer is going to be like 5 point something. Um, in fact, let me go ahead and write it like this. I know that the square root of 25 has to be smaller than the square root of 30. And that has to be smaller than the square root of 36. Okay, this number is too low. This number is too high. I know the square root of 25 is 5. I don't know the square root of 30, but I do know that the square root of 36 is 6. So what I'm trying to say is that my answer has to be somewhere stuck between 5 and 6. Like we're kind of sandwiching it between two numbers. Um, so if I were to take a guess, because 30 is kind of like in the middle of 25 and 36, and this is somewhere towards like pretty much almost exactly in the middle, I'm going to say my answer is right around 5.5 ish, right? And it's just a guess, but if if we were to try to calculate that, I'm pretty sure I would get pretty darn close. All right. Let's try the next one. It says between what two numbers is the square root of 70? So what we try to do is we try to find like my perfect squares. Again, we start squaring numbers and see which one gets close to 70. So let's see. I already know 36 is too low, right? Again, I'm trying to get to 70, and that was 6 times 6. So 6 times 6 was 36. That was too low. 7 times 7 is 49. That's still too low. 8 times 8 is 64. That's too low, but it's pretty close. So let me go ahead and start writing that down. 8 times 8 was 64. So that means the square root of 64 is 8. The next one, 9 times 9 is 81. So the square root of 81 is 9. And you notice that 81 is too high. So I was able to sandwich my numbers. I know that the square root of 64 is too low. And I know that the square root of 81 is too high. That means that this square root of 70 has to be somewhere in between this square root of 64 and this square root of 81. Let me go ahead and write that as an inequality. Square root of 64 is definitely smaller than the square root of 70, which is definitely smaller than the square root of 81. And I know that the square root of 64, well, let me go ahead and highlight these. Square root of 64 is too low. Square root of 81 is too high. That means my answer has to be 8 is less than the square root of 70, but the square root of 70 is less than 9. So my square root of 70, this answer, whatever it is, it's got to be stuck between 8 and 9. Now let's go ahead and do the trick that we did last time. Look at this 70. This 70, is it closer to the 64 or is it closer to the 81? Well, going this way, square root of 64, it's only 6 units away, right? Going this way, it's 11 units away. So actually, my square root of 70 is closer to this one, which means my answer is going to be closer to 8. Now, it's not super close. So I'm going to say, instead of calling it 8.5 like I did on the last one, right? Like right smack in the middle, I'm actually going to go closer to 8. So instead of 8.5, I'm going to say, I don't know. And again, this is just a guess. The square root of 70 is going to be right around 8.3. Not super close to 64, but not right smack in the middle either. Okay. All right, and then the last one we're going to do is between what two numbers is the square root of 20. So again, we start running with low numbers, perfect squares, and you just start guessing. So let's start at 3. 3 squared is 9. That's kind of close to 20. Let's do another one. 4 squared is 16. That's still too low. 5 squared is 25, and that one's actually too high. So it sounds like 4 squared and 5 squared is where I want to go. 4 squared was 16, so the square root of 16 is 4. That was too low. And then the square root of, let's see, 4 squared was 16. 5 squared was 25. So the square root of 25 is 5. And I know that the square root of 20 has to be somewhere between 16 and 25, right? So that means I'm going to go ahead and write the square root of 16 is definitely smaller than the square root of 20, which is definitely smaller than the square root of 25. I don't know the square root of 20, right? But I do know the square root of 16, and I do know the square root of 25. Square root of 16 is just 4. It's less than the square root of 20. It's less than the square root of, I'm sorry, the square root of 25 is just 5. And I forgot to highlight this. This is too high. This is too low. So my answer has to be somewhere between 4 and 5. Because 20 is 4 units away from 16 and 5 units away from 25, it's going to be pretty close to the middle, right? Like it's pretty darn close to the middle. So if I were to guess, I would say that the square root of 20 is right around, it's got to be between 4 and 5. So I'm going to call it like 4.5. And it's pretty darn close to the middle. And so we're just going to leave it like that. Okay, so hopefully that made sense. On number one, what is a square root? It's basically the opposite operation of squaring something. And number two, how to sandwich those numbers so that you get a good approximation of how much that number is going to be. All right. It says notes 5 squared equals 5 times 5, which is 25. And then 8 squared is 8 times 8, which is 64. And we did this in class the other day, but I think it's super important that you see this again because we're going to be using this a lot. Okay. X squared, if I were to follow that pattern, we said that x squared is the same thing as, like, 5 squared would be 5 times 5. So x squared is the same thing as x times x. That is so important. So I'm going to go ahead and highlight this on yellow, because from now on, whenever I see x times x, I need you to say that that answer is x squared. A lot of students will say x times x is 2x, and that is absolutely not true. But following this pattern, x times x is x squared because 5 times 5 is 5 squared, and 8 times 8 is 8 squared. So x times x must be x squared, okay? Let me write down the other one, uh, x plus x. That one is 2x, okay? So we'll highlight that one in pink. So that way you understand the difference between the two, okay? X times x is x squared. X plus x is 2x. Make sure you keep that in mind. We are definitely going to be using that a lot on this one. Okay, the next part we're going to work on today is distributive property, and we're going to extend the idea of distributive property. I know a lot of you guys have seen this with when it looks like this, but I noticed in class we had a lot of trouble when it looked like this. Okay, so we're going to formally introduce you to this concept and how to distribute when you have a binomial times a binomial. So let's work on the first one. What would this one look like? I got x and then parentheses x times 3, x plus 3. All I'm going to do is I'm going to distribute this x, and I'm going to go ahead and multiply everything inside the parentheses by x. So that means x times x. Remember, x times x, we just said in yellow, is x squared. X times x, that gives me x squared plus. And then I'm not done distributing, so I'm going to multiply this x times 3, and I get 3x. Now, I mentioned this earlier, x squared and 3x, these are not like terms. They're not like terms, so we cannot combine them, okay? If you had 3x's and then 4 more x's, like, okay, these x's and these x's are the same. Or if you have like 5x squared, then you have 5x squared and then 1x squared, that would give you 6x squared, but these are different. These are x's and these are x squared. They're not the same. We cannot combine them. We are stuck. That's as far as we can go on this problem. Let's go ahead and jump over to the next one. I'm going to go ahead and distribute the 2. That 2 is in the front of the parentheses, so I'm going to go 2 times 5x. That's going to give me 10x. I'm not done distributing, so I'm going to go ahead and distribute the next one. 2 times negative 8. 2 times negative 8, that's going to give me a negative 16. Again, 10x and negative 16, there are no like terms. I am stuck right there. There's nothing left for me to do, okay? Let's go to the next one. I got x that I'm distributing. X times 3x. You're going to call that 3x squared. The 3 stays alone. The x times x becomes x squared, so that's a 3x squared. That's how we got that. When you multiply an x times a y, you literally just put them together. So we're going to go ahead and distribute this. X times negative 7y, again, we're going to write that as the negative 7 just kind of stays. The x times y just becomes xy. And so we just literally just took the x in the middle of all that, okay? And then proper notation, you always go in alpha, so x goes on the left, y goes on the right. Okay, so that's the basic stuff. Let's go ahead and start jumping into the more complicated things and see how this works. Here, some teachers are going to teach this as FOIL. I'm just going to teach it as distribute and then distribute again. We're multiplying two binomials. What do I mean by that? I mean, I have this x plus 7 that I need to multiply with the x minus 3. We're going to treat this as we're just going to distribute everything. So I'm first going to distribute this x over to the other parentheses. When I do that, I'm going to get x times x, which is x squared. I'm not done distributing that x, so I'm going to multiply x times negative 3. And what I get is negative 3x. At this point, I am done distributing that x. So I'm going to go ahead and move on to the next part. Since I'm done distributing the x, now I need to distribute the 7. Okay, so I'm going to do this in a different color. I'm going to do this in green. I'm going to take that positive 7 and I'm going to distribute it to everything in the other parentheses. This is going to be 7 times x, which is 7x. This is going to be 7 times negative 3, which is negative 21. Now I am done distributing the 7 and I am done distributing the x. I'm done distributing overall. So this problem is almost done. The only thing we need to do is we need to combine like terms. So again, I don't see any other x squared, so the x squareds are done. As far as x's, I see a negative 3x and a positive 7x. I can absolutely combine these two. Negative 3x plus 7x, that gives me positive 4x. So I'm going to write x squared plus 4x minus 21. And that is my answer for that first one. Now that's the way I teach it, okay? When you have a binomial times another binomial, other teachers will teach it as FOIL it, okay? What do they mean by FOIL? They mean you need to multiply the first two, the outer two, the inner two, and then the last two. Okay, that's where the FOIL comes from. Go ahead and write that on the side. Some of you guys are going to like this. I personally don't, but it might come in useful later. Okay, so this means multiply the first two. What do they mean by the first two? They mean take the first one here and multiply it by the first one here. So this is the first term times the first term, and you get x squared. So this is where my f comes in. Let me go ahead and kind of jot these down. My f comes right here. This is how I got that x squared. I multiplied the first term on each one. The O stands for the outer two. Outer two means multiply the ones on the outside. So this x is on the outside. This negative 3 is on the outside. So they're talking about this loop right here. I'm going to go ahead and put an O out here. Multiply the ones on the outside. That's x times negative 3, which gives you the negative 3x. There's where that O comes from. The I stands for the inner two. So the 2 on the inside, we're going to go ahead and multiply. The ones on the inside, that would be this 7 and this x. Those are like this little mini loop right here. So I'm going to put an I right there. That's 7 times x. That's going to give you a 7x. And oh, look at that. That I also goes for that 7x that you see right there. And then the last two, the L stands for the last two. That means on each parentheses, you're going to multiply the last two things. So you're talking about the last, let's see. So this is the last one from this parentheses. This is the last one from this parentheses. You're going to go ahead and multiply the 7 times the negative 3, and that gives you the negative 21. So there's your L right there. Okay, so that's what they mean by FOIL. Which one do you like better? I don't know. Everyone's a little different. I personally don't like it, but other students do. So I'm just going to keep flip-flopping back and forth, and then we'll see what you prefer. All right. In fact, on this one, I'm going to go ahead and use FOIL just so you can kind of see the process. So again, we're going to multiply the F, the O, the I, and the L. The F stands for the first two. So the first two, that means from each one, this is the first term, and this is the first term for my parentheses, right? So I'm going to go ahead and multiply those. That is my F. X times X, that gives me an X squared. I'm done with the F. The next one I'm going to do are the outer two. The outer two are the ones on the outside, so that would be the X, and the negative 3 are the ones on the outside. go ahead and write, this was my f. The ones on the outside, that was x times negative 3. That's a negative 3x. Those are the outside ones. Now I'm done with that. My O, I'm going to go with my I. I is for the inner two. The inner two are the ones on the inside, so that would be the negative 7 and the x. Those are the two numbers that are in the inside, so negative 7 times x. That gives me a negative 7x. That's my I. And then L stands for the last two. The last two, that's the last one from each one. So it'd be the negative 7 and the negative 3. So from each parentheses, the last two, negative 7 and negative 3. Negative 7 times negative 3, that's a positive 21. That's my last two. So again, I don't know whether you like the FOIL method or not. I do know that the FOIL method is going to come into play later. So it's good that you know what it is. But if you like it, great. If you don't like it, great. Like, as long as you know how to do it one way, it doesn't really matter to me which way you do it. Okay. So now that I have my FOIL, right, I've already done it. I'm going to go ahead and combine like terms. The x squared does not join up with anything, but the negative 3x does join up with the negative 7x. That gives me a negative 10x. So I get x squared minus 10x plus 21. And that's as far as I can go with that one. This becomes a trinomial because it has 3 terms in it. All right. Let's go ahead and do this next one. I'm not going to FOIL this. Like I said, I'm just going to keep flip-flopping, and then you tell me which one you like better. So this time I'm going to do it without FOIL. Remember, this method is just distribute and then distribute again. Okay. So the first thing I'm going to do is I'm going to distribute this 2x. This 2x times x, it gives me 2x squared. I'm not done distributing the 2x, so I'm going to distribute again. 2x times negative 5, that gives me a negative 10x. I am done distributing the 2x, so now that I'm done distributing the 2x, I'm going to distribute the 3. The 3 times the x gives me the 3x. I'm not done distributing the 3, so I'm going to distribute again. 3 times negative 5 gives me a negative 15. I'm done distributing the 3. I'm done distributing everything in that first parenthesis, so I'm pretty much done. I just need to simplify. I'm going to go ahead and combine like terms. I know the negative 10x and the 3x will combine. What I end up with is a negative 7x, so I get 2x squared minus 7x minus 15. And we are done with that problem. Hopefully you start understanding, like, this really is not that hard. It just depends what method you're going to use. Again, I'm flip-flopping, guys, so in this case, I'm going to go ahead and use FOIL. So let's see, I'm going to go ahead and multiply the first two. The first two, that would be my x times x. That gives me the f. X times x gives me x squared. And I'm done with the first two. Now I'm going to go ahead and multiply the ones on the outside. The outside ones, that would be the x and the 10. X times 10, that gives me 10x. I'm done with my outside ones. Now I'm going to multiply the ones on the inside. The inside ones, well, those are the ones that are stuck in the middle. That would be the 9 and the x. That gives me 9x. And then I just got to multiply the last ones from each parentheses. So that would be the 9 and the 10. Those are the last two on each parentheses. And 9 times 10, that gives me 90. Sorry, I forgot to write that. This was the inside two. These are the last two. Now I'm done with my FOIL. Once you're done with your FOIL, you're going to go ahead and combine like terms. 10 and 9x, that gives you 19x. X squared plus 19x plus 90 is your final answer. Okay. This one looks very similar to the one on top. You see how it says x minus 7, x minus 3? On this one, it says x minus 3, y minus 7. So let's see how that changes. I'm going to go ahead and just distribute this time to kind of just keep flip-flopping on you. Let's start with the first two. Let's see. I got this x. I'm going to distribute that x. X times y gives me xy. I'm not done distributing the x, so I'm going to distribute again. X times negative 7 is negative 7x. I'm done distributing the x. I'm going to move on to the y's. I'm sorry, to the negative 3's. Take that negative 3 and distribute it. Negative 3 times y is negative 3y. Negative 3 times negative 7, I still need to distribute that one, and I get a positive 21. As far as combining like terms, I don't see any other xy's. I don't see any other x's. I don't see any other y's. And the 21 is just a 21. So there are no like terms to combine. This is as far as you can go. So we're going to go ahead and leave it like that. Okay. Okay. And then you get to this one. Now, when you get to this one, FOIL will not work. Let me explain why FOIL doesn't work. FOIL doesn't work because there's 4 letters in FOIL, right? There's 4 letters. That means you're doing 4 things. FOIL has 4 things, but when you start distributing, when you take this x and distribute it, you're going to distribute it here. That's 1. Here, that's 2. Here, that's 3 things you have to distribute. Then you're going to go to the 3, and you're going to distribute it here. That's 4. Here, that's 5. Here, that is 6. You're supposed to distribute 6 times, but when you use FOIL, you're only doing 4 things. So if you were to try to FOIL using this, you would be missing 2 of the terms that are required. So that's me personally why I don't like FOIL too much, because FOIL only works when you have 2 things and 2 things. As soon as you start messing with other sizes, your FOIL's not going to work anymore. Okay. So obviously on this one, we're not going to use FOIL because again, you need to have 6 different answers, and FOIL only takes care of 4 of them. So let's go ahead and start just using the distributive method. I'm going to take this x and I'm going to distribute it. X times x squared. Now I want you to think of what that actually looks like. That's x times x squared. If I were to write that the long way, that would be x times, remember x squared means x times x. Well, that says x times x times x, which is x to the 3rd power. Okay, there's 3 x's there. So x times x squared is going to be x cubed. When it's to the 3rd power, we say it is cubed. I'm not done distributing that x. I'm going to go ahead and multiply x times negative 4x. There is no number associated, so we're just going to keep that negative 4. And then x times x gives me a negative 4x squared. And then I'm going to go x times negative 8. That gives me a negative 8x. And I'm done distributing my x's. Now that I'm done distributing my x's, I'm going to go ahead and distribute my 3's. So I'm going to take my other colored highlighter. I'm going to take that 3 and I'm going to distribute it. 3 times x squared, that is 3x squared. 3 times negative 4x, that is a negative 12x. And then 3 times negative 8, that gives me a negative 24. Now that I have that done, now I get to go ahead and combine like terms. Just like before, the exponents need to be the same in order for you to combine like terms. So for example, I see that this is an x cubed, or x to the 3rd power. I don't see any other x to the 3rd powers here. And so that x cubed is by itself. As far as x squareds, I see negative 4x squareds here. This is not an x squared. This one is another x squared. So this one is going to be able to join up. I got negative 4x squareds with positive 3x squareds. If I were to combine those, it sounds like I would have negative 1x squared. But instead of saying negative 1x squared, I'm just going to say negative x squared. And I'm sorry, I just realized that I wrote x squared on the last one. That is a mistake. This should have been x cubed. Sorry for that. So I have an x cubed because it did not join up. I got a negative x squared because that joined up with these two. Now that I'm done with my x squareds, I'm going to go to my x's. X's, I see negative 8x's here. I should circle those. I see negative 8x's here and negative 12x's here. If I put negative 8 with negative 12, that gives me a negative 20x. And then as far as constants, I have a negative 24, and that's as far as I can go. Okay, so that takes care of the notes for today. As always, if you have any questions, please feel free to ask.